Today's lesson is a review of some skills that you've worked on in both grade 9 and definitely in grade 10 last year. Okay, so the first thing that we're going to be looking at for prerequisite skills for our unit is expanding. And so we're looking at everything dealing with operations with polynomials. Okay, so first of all, the first operation we're going to look at is both adding and subtracting. And because they're reverse of each other, that's why they go together. So you have in front of you the steps. So the first thing we would do is we remove any brackets around the polynomials and then combine like terms. It's pretty much simple as that. The only difference is when we're subtracting, we're always going to add its opposite. What that really means for us is we're going to change the signs of the polynomial that is being subtracted. So let's take a look at a few examples here. As I said, review of what you've done before. So our first example, you can see we have two polynomials, okay, and we can see the polynomials, they have brackets around them and we're adding. So because we're not subtracting, all we have to do is take the brackets off. So that's what we're going to do. So we're going to start with an equal sign. We have m plus 2n, and as I said, we take off the second bracket. So now this is what we're left with. Now what we're doing is we combine like terms. Now remember, a like term is a term that has the same variable, okay, in other words, the same letter, raised to the same power. You can see we have two variables here. The two variables we have are m, and we also have n's. So I'm going to underline our m's. So we have 1m plus 3m, so we know that that is going to be a 4m. And then we have a 2n minus a 5n, so we end up with minus 3n. Okay, pretty simple. Next one, almost the same idea, except this time we are subtracting. Notice there's lots of negative signs here. So according to the steps, it means I take off the brackets, but this one here, and I'll use the magic pen, this one here, this polynomial is the one being subtracted. So instead of doing plus 3, you're going to put a minus 3. Instead of a negative 4y, we're going to put a positive 4y. So that's what we're up to next. So we just do that, and negative y plus 2 and minus a 3 and a positive 4y. Okay, and again, just like the previous example, what we're going to do is we're going to gather like terms. Going to make my eraser a little bit different. So again, equal sign directly below the equal sign, the line above, negative y and a 4y. So we have a 3y, and a positive 2 and a negative 3 is a negative 1. So adding and subtracting polynomials, pretty straightforward. As I said, that's a skill that you were doing all the way back in grade 9, maybe even grade 7 and 8, possibly. And the next one, it looks harder than the previous two, but really all that they've done is they've added some more terms to each polynomial. So the same thing applies here. What we're going to do is we're going to take off the brackets. We have adding for our second polynomial, so it's just a matter of taking off the brackets. So we end up with, let's take a look, 5a squared minus 6a and a positive 3 plus 2a squared minus 3a and our negative 1. Again, we're collecting like terms. This time we have a's, but we have also a squared. So the a squareds go together, so a 5 and a 2. So we have 7a squareds. We have a negative 6a and a negative 3a, so a negative 9a, and a 3 minus 1, so that's a positive 2. All right, let's look on some next operations. The next operations we're going to be looking at is multiplying. And multiplying really is just variations of the distributive law. So when we look at the first example, here it is here. So we can see that we have negative 2x and it's being multiplied by everything in the first bracket, so multiplied by the first variable, and then the negative 5x is multiplied by the second variable. So literally what we do is we take all of this and we multiply it by the first one. So a negative 2x times a 2 is negative 4. And where is it? There it is, negative 4x, negative 2x times a positive 3x. So we end up with a negative 6, but we have an x times an x, so we're going to end up with a negative 6x squared. And now we're on to the next part. So negative 5x times a 2x, so negative 10x squared. And lastly, we have a negative 5x times a 5, so a negative 25x. Okay, again, just like our previous examples, now all we're doing is we're gathering like terms. In most cases, I would probably put the x squared terms first, so a negative 6x and a negative 10x, so a negative 16x squared, followed by negative 4x and a negative 25x, so we have a negative 29x. Next question is what you've seen as FOIL before. Now notice that what I did here is I put A's and B's and X's and Y's, so I didn't have anything that were in common to begin with. And now FOIL is first, outside, inside, last. And you can remember how to multiply it like that if you so wish. Often what I do is I take the first term, multiply it by everything in the second bracket. Then I take the second term and multiply it by everything in the second bracket. And actually that's what FOIL is. First, outside, inside, last. And you can see that works the same way. Now the reason I often take the first one and multiply it by everything in the second and the second by everything in the second second polynomial is because it's possible I could have a variation on this, and I could actually have 3 terms in the first polynomial. And so FOIL by itself doesn't work, but my method always will. So let's try doing this now. So a times an x, so we're going to have ax, and a times a y is going to be a positive ay. Then we have, get the y there, then we have b times an x, so we end up with a bx, and a b with a y, we end up with a by. Now the next step that we did with everything else is we gather like terms. Now if you look here, because I didn't give us numbers, everything was variables, there is nothing in common here. So that's where you would finish that one. Okay, over to the next part of the lesson, and again it has to do with multiplying and its special patterns. Now some of you remember these special patterns, maybe you don't. Okay, the first special pattern is this one here, and we actually call that one difference of squares. So what happens is we have 2 brackets that are identical except that one is positive and one is negative. So what happens is if I do FOIL, the in between terms, the AB and the BA are going to cancel out each other. So what I'm left with when I do that is just going to be a squared minus b squared. Okay, that's why they call it a difference, because it's minus squares, a squared, b squared. The next two are related to each other in the sense that both brackets are identical. And so what you could do is you could literally write it as 1 bracket squared. Same thing here, 1 bracket squared. Okay. And when you do this, this time you will have a middle term. And the middle term that you're going to have is going to be 2 times the A and the B. So what happens here is it's somewhere in here, and now it's not showing up for me. And this is sometimes what happens with these lessons. So let's take a look. I'm maybe not getting it in the right spot. I guess not. So what I'm going to do is I'll just use this to come and give it to me. So what happens, it's this term squared, a squared. It's a times b times 2, because that's what would happen if I did FOIL. If I did FOIL, I'm going to have 2 of those terms. So I'm going to have 2ab, and then I'm going to have the last term squared, which is b squared. And this one below it is almost identical, except the difference between the 2 questions is in this bracket here they were positive, in this bracket here they're negative, so I end up with a negative 2ab. However, my b squared is also going to be positive. Okay, and we call these what we call is perfect squares. And I know I have that behind there somewhere, and I'll just move it out here. So those are called perfect squares. So let's look at a couple of examples. Now again, you can see they've done combinations. They don't give it to us exactly usually in this format. They add something to it. So the first one, you can see I have 2 times a perfect square. So I can't just go and take this 2 and put it into this bracket because our order of operations says I must do brackets, exponents, which this is, um, multiplying and dividing. So the 2 is a multiplying. I have to do the exponent first. So I just leave the 2 outside the bracket. And sorry, I'm writing with my cursor right now. So it's going to be this pattern here. So it's going to be x squared. This times 2, so that's going to be minus 6x. And finally, the last term squared, which would be a 9, positive 9. And then it's just a normal distributive law. I bring in that 2, so I have a 2x squared, a 12x, sorry, a minus 12x, and pretty sloppy writing, I know, with my mouse. And 2 times 9 is going to be 18. Now we'll do the next question. The next question is actually easier because when I look at this, both brackets are the same except one's positive, one's negative. So that means it's a difference of squares. So in this case, all I do is I take the first term and square it. So 3 squared is 9, x squared is x squared. Sorry, x squared is x squared. And 2 squared is going to be 4, and its difference is square, so it's going to be subtracting. So it's actually quite that easy. Okay, what you're going to do now is you're going to do some practicing next day in class and have lots of fun.